So our strategy for graphing a line using its intercepts is that we want to find the y-intercept for this line by setting x equals 0. Find the x-intercept of this line by setting y equals 0. Again, the reason that works is that if I'm setting x to 0, then I'm talking about the y-axis. And if I'm setting y equal to 0, that means that I'm talking about the x-axis. So once we find these two intercepts, all we have to do is plot them. Just plot those intercepts on our plane and then connect the dots, because there's only one line, and only one line that passes through a set of two given distinct points. That's going to be the strategy that avoids any algebra, really. There might be a little bit of algebra, but not that much. Option 2 actually uses the y equals mx plus b format. And what it does is it takes the line which is given to us in standard form, and we do the algebra that's necessary to rearrange that equation into a format where y is by itself. So we're going to solve for y to get it in a format where we can say y is equal to mx plus b. Then we'll use that value for b to plot the y-intercept for this line, and then use the value we find for m, which is the slope of this line, to what I like to call stair-step, from that y-intercept that we plotted up to any other point on this line. And then as soon as we have those two different points, then we can connect those 2 points with a line and we're done. So let's look at the two different strategies in action. For option 1, let's first start by finding the y-intercept of this line. And again, to find the y-intercept of any equation, all we have to do is set the x value equal to 0. So in place of the x, I'm going to put a 0, simplify, and I end up on the left-hand side with negative 5y. On the right-hand side, I still have negative 5. And if I solve this equation for y, I'm going to get the y-coordinate of the y-intercept of this equation. To solve, all I have to do now is divide by negative 5 on both sides to find out that y is equal to 1. Therefore, the y-intercept of this equation, which happens to be a line, is the point where x is equal to 0, but y is equal to 1. So let's place that right on our graph right now. So that's for the y-intercept. For the x-intercept, we have to do exactly the opposite thing. For the x-intercept, which lies on the x-axis, we just need to set the value of y equal to 0. After all, the equation for the x-axis, the equation which describes the x-axis, is the equation y equals 0. So in place of that y in the equation, I'm going to put a 0. Simplify what I have on the left-hand side. My y term is going to go away. I just have 2x equals negative 5. And then dividing by 2, we'll find that x is equal to negative 5/2. Or if you like decimals, it's negative 2.5, negative 2.5. So the x-intercept for this equation has an x value of negative 5/2 and a y-coordinate of 0. Let's place that point on our graph as well. And now we've plotted both of the intercepts of this equation. Since we know this equation is going to be a line, based on knowing what the standard form of an equation for a line looks like, all we have to do now is connect the dots, and we're done. And that's the beauty of taking this option. We didn't have to do anything terribly sophisticated, algebraically, certainly. All we had to do was locate these two intercepts, and because we know that as soon as we have two different points on our line, we can just connect the dots and be done, that's all we did. So we found the y-intercept by setting x equal to 0 and solving for y. We got y equals 1. We found the x-intercept by setting y equal to 0 and solving for x. We got x equals negative 5/2. Then just plotting those 2 points on our graph paper and connecting them with a line was all we needed to do to take option 1 in this example.